Hey everybody, welcome to the Vizela Xweather Developer Q&A. This is continuing the series here. This is our third, talking about our products, our latest MapsGL, which is our latest mapping engine for visualizing weather and geospatial data in innovative and unique ways. I think I got that good. Previously, we've done the Eris API, which is our data API. Oh, I said Eris API. That's the first ding. Dang it.
Ding.
So the weather data API and our raster maps, those links we have in somewhere that Holly's made for us. But we can refer back to those, which is great. But these have been really fun. We have the opportunity to address customer questions and meet and interact with you folks to get feedback on these tools we make. We're a weather and environmental data company who makes tools to really help users tell their stories, protect assets, do all the things that we do. But primarily, we're here to build tools for you. So whatever feedback we can get, we absolutely love. I'm Seth Miller. I'm the data core team lead. Switch those up a little bit. In my team, we have the opportunity to ingest data, build the APIs, and more of the backend technologies. We control the MapsGL API, the actual like data service, but all of the pretty fun stuff is taken care of by Nick and his team. And Nick is sitting next to me.
Yeah, I'm Nick. I'm the engineering lead for the SDKs and toolkits, and I'm also a designer at Xweather. And then we also have Slipp.
Hi, I'm Slipp Thompson. I'm working on the Apple platforms version of MapsGL and some of our other stuff. So primarily iOS, iPadOS, but macOS is rolled into that as well, visionOS, and hopefully more in the future. Hopefully all the Apple platforms.
And hi, everybody. I am Holly. I am the Weather and Environmental Data Marketing Manager here at Xweather, and I will be your question moderator today. So good to meet you all. Welcome. So just to kind of kick us off, we did get a couple questions looking for really a general overview on MapsGL. Nick, you've been a software developer here since the HamWeather days. So I think it's been, 14 years now? Yeah. So, obviously formerly Xweather, and before that, longer history is HamWeather. So around 2018, you started to dream of a vector-based weather mapping platform. Can you talk a little bit about what that looked like and how we got to the point of launch and how it now has become this MapsGL product that we know and love?
Sure. Yeah, so at that time, a lot of our focus was spent on the raster tiles and data services that we still provide today. And at that time, we saw a lot of limitations to the raster services that we provided in terms of like customization and styling. We had a lot of clients requesting custom color ramps, custom styles, custom font sizes, stuff like that for those data sets, which rendering all of that server side, it would require a lot of resources on the back end to kind of support that for the clients. So those were some of the core limitations. But then also animations between intervals aren't smooth. If you're animating radar or temperatures, you get a very stepped sort of animation between each interval. And you also incur a lot more data requests. So if you're rendering like a full map view for a desktop or something like that, even as you zoom in, the data resolution isn't necessarily increasing. So if you get like a low res temperature data set, like some of our models, then as you zoom in, you're still requesting a lot more data, even though you don't need to, because the data resolution isn't changing.
Mm-hmm.
So that was another factor with the raster tiles. And then some other aspects is you don't have access to the raw underlying data. So if you wanted to like filter the data, say for alerts, if you wanted only winter alerts or tropical alerts, you couldn't filter that data. You were limited to what we provided on the back end. And then also you can't actually like query the data for specific points like temperatures or alerts or anything like that.
Right.
And that's been a challenging one, just to jump in there too. Alerts are really tough because they're all like different colors, especially in the US. The US alert palette is all over. This happened, was it over the weekend? A huge chunk of Minneapolis lit up like dark red. I was like, oh my God, this is like, a tornado warning or something right over my parents' house. And I was like, geez, but it was like a flash flood warning. And it's like, well, with these raster tiles, it's a little harder because you have to have the legend and you have to like reference. Having that interactivity is really helpful and really helps bring that user experience up a notch.
Yeah.
Awesome. Yeah, I mean, it sounds great. So it all sounds unique, but one of the other questions was what makes MapsGL unique?
So the styling is one of the big things. So with the raster tiles, it's very quick and efficient, easy to get started because we do all of that for you. So all the styling is done server side. You just request the tiles and you get the tiles on your map. But with MapsGL, you have full control over the styling. So if you want specific color styles for like temperatures or wind speed or radar or something like that, you have control over how that gets visualized. And maybe your application wants to be more kind of reflect your brand or something like that. So you customize the styles and colors for that, or like wind particles, you can control the density, speed, and stuff like that.
Wind particles were a big one.
Another thing is with MapsGL, it kind of acts more as like our weather API. So we provide you the data and you control how that gets visualized versus us kind of defining how that data is visualized. And then also with MapsGL, you get smoother animations. So instead of the stepped animations you get with raster, you can smoothly interpolate between timeframes across a time series. And then you also get more unique rendering capabilities like wind particles to visualize flow fields and stuff like that.
Beautiful. Yeah. And so we launched MapsGL in, I believe it was May of 2022. And we've had some really incredible improvements to it along the way, really incredible additions that have come out. There's more coming. So that leads me into, Seth, could you give us a little bit of an update?
Yeah, so for those who've been following us for a little bit, this is probably the most relevant for you. But if you're new to it too, Nick and Slipp have some great demos that they're going to kind of show off as we go here. But there's new text layers that are doing real-time rendering of data values that are pretty slick. Here, we'll flip over to the screen share. There we go. So this is Nick piloting this for us. These new text layers, yeah, real-time rendering of data layers. They cross-layer reference each other. And yeah, Nick, can you speak more on that?
Sure, yeah. So what this is doing is taking the underlying temperature data, which is also rendered below the text here, and it queries for, right now we're using predefined points that we provide through MapsGL, and it queries each point and displays those values in real time on the map. But the other cool thing with this is you can provide your own unique set of points through either GeoJSON or a vector tile set as well.
Yeah, so if you have facilities or certain locations that you're concerned about, you could use those custom points specifically for the assets that you're controlling. And those text items aren't tied to the current layer, right? You can choose a different layer as well, like underneath. Oh, okay, awesome.
Yep, so if you wanted temperatures, just the text, you can only show the text and then just hide the underlying data if you want, or you can keep the data on there.
Yeah, or choose like a humidity or something else underneath with temperature on top. Awesome. But then another particle effect, because the particles are the most fun. The wind arrows are pretty cool. Yeah, awesome.
Yeah, so this is similar to our main wind particles layer, but instead of the actual particles, we're rendering arrow symbols. So this isn't only limited to arrows. Like you could do pretty much anything you wanted for particles. But we thought arrows was a cool one to kind of show off.
Excellent. And then along with that, making MapsGL that complete solution, we have administrative layers for boundaries, waters, roads, places. So we actually provide the base layers as well. So you don't need a secondary subscription to a data provider for base maps. We have that kind of base layers and administrative layers, a lot like we have with our raster mapping tools. They're available in MapsGL as well. So we can be that kind of one-stop solution for you, and you're not having to integrate too many things together. And you can see there. Yep. Excellent. So yeah, different map units per data element. This stuff is all just coming off of our changelog that Nick posted for us. But then there's other bug fixes, improvements all throughout. So I'm going to flip us over here to what Slipp has been working on with the Apple side of things, iOS, iPadOS, Mac side, like he was saying. That's on 1.0.2 now after a couple fixes he's got in. This is our stable release. It's on SPM, CocoaPods, and the direct download for the XE frameworks. And what's really been exciting about this is it's not just a wrapper around the JS version. This is written in Swift. It's using Metal, and it has a lot more performance associated with it. And he's got the core features and data layers all set up. I'll switch over to you now.
So this is the what we're looking at right now is it's a public demo on GitHub. You could download this, put in API keys, and run it today. And of course, it's using our iOS SDK, which is in many ways very, very similar from a client perspective to the JavaScript SDK. The goal is feature parity and the front end API being almost the same, but underneath it's using, like Seth mentioned, native rendering technology to get great visual performance, 120 FPS on pretty much every device that can support it. But at the same time, that also means lower battery usage and just won't hurt your the end user app's performance and device temperature and everything like that. Just smooth, good performing maps. So we can load in a couple layers here. Of course, we have weather here as well, or temperature, I should say. Loads in from the server fast, all that. That was actually feels like we've got some of the more, because one of the things we can do both in the JavaScript and native is weather layers that are based off of a couple different data sets and do calculations on device. So this is 24-hour temperature change.
Ooh, we're going to talk more about that later.
Yeah.
We
Good
will
segue.
talk about that more. Yeah. Just the feature parity, you know. We have, of course, I had these up earlier, wind particles. We've also got some other cool particle layers like the ocean current particles here are always
Maritime
very
is a
pretty.
big one. Very pretty.
So I love those.
They're very swirly. They're more swirly than the regular
Right,
winds,
yeah.
aren't they?
And the like custom color ramps, that type of stuff, also parity with the JavaScript version. So yeah,
It's crazy how fast it is on device.
Yeah, this is running on my
Nice.
phone over there. It's just Slipp's playing with it on the phone. That's awesome.
this is a fairly new phone. But, we have a couple test devices that are 3, 4, 5, 6 years old, nice and fast. So that was the goal, and that is what we will continue to do.
Excellent. So yeah, as we keep going here, Android has reached beta 1, which is great. So that's available with a demo on GitHub. So just like these other platforms and SDKs, I mean, we're looking for feedback on that. If you have use cases, please let us know. Like I said, we build these tools for you guys. So as you keep pushing forward with these, please give that a shot. Yeah, it's also got a great old Maven build. And then the core rendering and data layers, that's what's done right now. So a lot of the core functionality is there. And able to be integrated. It's using Mapbox as a base map right now, though we have others planned in the future once we get a lot more of those features built out.
It's timely, actually. We just got a question from Jonas on when do you anticipate to have the Android V1 released?
That is scheduled for this fall. So the initial beta was just released, I think, a couple of weeks ago. And 1.0 is scheduled for sometime in September.
Great. Awesome. Thank you.
So upcoming, now that was kind of all the things upcoming, JS SDK side, Slipp was talking about some of the cool capabilities this provides of being able to take different data sets and put them together, which is a huge differentiator over raster maps where maybe it's like, well, you can make it like a little transparent. It's like, well, now we can do some really cool things. So the raster timeline animation support That's going to be just animating the layers, which is pretty cool, of the raster map. So you can bring those in. So if there's some over there that you want to play with, some really cool stuff, if you have custom layers, that's really neat. But I was going to show the mathematical stuff, mathematical operations, I'm calling it. So if we run this, what are we looking at here, Nick?
So this is taking 1 hour forecast precip for multiple intervals and just summing them together. So it essentially creates an accumulated precip data set out of just using some existing data sets that we have.
And for those in the weather space, the QPF is what that's referred to a lot, but a lot of the QPF data you'll see out there is basically just from model start. So even though the forecast model maybe started at like 0Z, if you're trying to tell your story of like, well, here, the storm we know is coming through our area. Sorry, I'm rapidly clicking on this, trying to restart the video. The storm is coming through our area maybe, tomorrow through the weekend or something. Well, then you can show that, you can tell that story of like, well, we can just start accumulating it from out in the future to maybe the next day, which is really cool and a really unique capability that we have. And then this shows as well. Yeah, jump in.
Yeah, so you have full control over kind of what that time range is. So if you want to show accumulated precip over 24 hours or 7 days or 15 days, you can specify that and it'll start exactly where you want it and kind of end where you want it. So,
and then it even shows like with the tool tips and stuff, so you can get sort of like a storm total or expected total as a system moves through for that period of time, which is really neat. And that's all happening live underneath the cursor, which is pretty awesome. We have a couple more cool ones here. Clicky, click, 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 click. So what is this? Is this max temp?
Yeah, this one is max temps over 7 days. So it essentially just calculates what the maximum temperature over the 7-day period is and displays it in real time.
And these are some really cool functionality. We're still working on these. Still working on making sure the performance is there. Oh, this one's cool.
Yeah, this one is max wind speeds over 7 days, and you can see Hurricane Beryl as it moved into the Texas coast. It's kind of cool.
Yeah, you can see it just move all the way up and then start cutting east. That is awesome.
The barrel animations were great.
So back to the slides real quick. Yeah, and then Apple SDK side, working on timeline-based animation. That will be coming soon. And then
that is one of our most requested features and is next up on the docket. That will be 1.1.
Nice. And then additional mapping libraries as well coming thereafter. Then there's already a question about the Android SDK. Glad there's excitement about that. Just those additional features and then changes based on user feedback that we get. So yeah, if user who's excited about the Android release, yeah, please give it a go and let us know and start integrating it. Yeah, we're excited to hear about it.
Definitely.
So that's what I have for releases. Question time.
Yeah, that's perfect. So the first question beyond kind of the overview stuff is still an overview, but it's specific to the Apple Platforms SDK for MapsGL. So Slipp, could you give us an overview?
I kind of covered a little bit of that before, just the parity to MapsGL JS. But I guess going maybe a bit more high level is that essentially it is a library to add our weather layers and our rendering to other host mapping libraries. So right now, initially, it's Mapbox for iOS that we support. We're working on Map Libre and Google Maps as well, and basically getting all of our high quality rendering and computation, everything working smoothly, no matter what mapping library you use in your app. And that we have sample code in our documentation and on GitHub. That is essentially the core of it. Is the demo app is create a Mapbox map, set it up, call our add weather layer, and you're off to the races with lots of customization points for the color scales and styles and everything else.
That was one thing I didn't really point out with MapsGL in general is we strive to be kind of mapping library independent. So a lot of all of our rendering stuff is independent of which mapping library you're using. So with JavaScript, we support Mapbox, Map Libre, Google Maps and Leaflet. And then the native versions will support most of those, and then maybe some additional ones depending on what's popular for those platforms.
Yeah, and we understand, sorry, Slipp, real quick. We understand that we're a component probably of what you're trying to build. So as you're building out your application to manage whatever assets, if you have buildings, vehicles, whatever you're tracking, we're probably a component in that.
Yep.
So we wanted to make it really easy to just put our information along with the type of information that you already have.
Yep.
So
Exactly.
being able to support all of those different use cases is really important to us.
Yep.
Awesome. Yeah. So somebody had also asked specifically about how they can improve mobile applications with MapsGL, which really is perfect for the Apple Platforms SDK. Could you share a little bit about how MapsGL gives a unique edge to mobile offerings?
I mean, the work we've done on native meta rendering and performance, of course, is one of the biggest ones. Not only does it look great, feel like an Apple product because it just works smoothly, responsive. The battery life stuff I mentioned just keeps everything chugging along well, and somebody can have your app up on their device and be out on a lake or in the woods or whatever the use case is, and they don't have to worry about their phone dying on them as much as they might with solutions that aren't as native. So high performance is a big aspect. The integration with other libraries that we talked about, if you're using other things from other places, if you want these annotations or this kind of base styling from Mapbox or somewhere else, our weather layers can fit into all that. And basically just, being able to integrate our customizable weather layers with whatever else you're doing.
Yeah, it's a really great opportunity for custom branding as well, because you can bring all of your own custom colorways into the fold, and you make beautiful visuals with that.
Marketing chiming in with the custom colors. We got to make it look nice.
The custom icons, yeah. If you wanted to make a little logo, have your icon be your logo, great. Do it. So my next question is for you, Nick. We had somebody ask about integrating custom layers into MapsGL with animations. So could you talk a little about that?
Sure. So we do support bringing in your own custom raster layers into MapsGL, and you can render them through our rendering engine. We are also currently in development is support for animating those, which will allow you to, like, say if you have your own custom time series data, like maybe you have a high resolution model data set for like wind farm or something like that.
Mm-hmm.
That's like very localized.
Yeah.
You want to animate across time. You'll be able to animate that as well, as long as you provide the time series data in valid times.
Beautiful. Yeah, those custom layers are really fun integrations.
Yep.
And then another question for you is how to properly set up Map Controller in React with newer Mapbox versions.
We get that a lot. React. So
yeah, do you want to flip over here? Perfect.
Yep. So for React, we have developed this React MapsGL open source library. It supports Mapbox, MapLibre, Google Maps, and Leaflet. And it works very similar to some of the existing React Mapbox libraries that are out there. So within this README, you can see an example of how you can set up your MapsGL map controller with timeline, map controls for like data inspectors and stuff like that. And then also add in your own weather layers from MapsGL in a very React sort of way, with still that same full control over customization options. And I think you'll be sharing this in the links.
Yes.
For that.
Yeah. Well, I've got not a link to the React specifically, but to our GitHub. Okay. Yes. Yep. And that was shared. We'll share all of these links as well in a follow-up email. So everyone who's here and everyone who registered will get a follow-up email that has all of these great links and resources in them too. So fantastic. I see a lot of really great questions that came in from the audience. So we're going to start walking through some of those. I'm going to try and start from the beginning. So Jonas, another great question from Jonas. Do we have access to the raw data that the MapsGL SDK uses?
We don't provide like the actual requests that it's making, but you do have access to the underlying data. And within the map controller of MapsGL, you can call this query method, and it'll query all of the active layers and return all the data returned from those layers. So as you're moving either your pointer or your mouse over the map, you can query the map, get data at that point, and it'll return those values.
Awesome.
Backend developer Seth here. Very curious about your use case though. So if you're like, oh, I want this like gridded data in some way, let us know. Curious about that use case, if it is a visualization use case or if it's kind of something else you're looking to do. Let us know. That's cool.
Mm-hmm. Yeah. Our next question is from Ziad, and it's great to see you back, Ziad. In your last session, you announced that the Lightning endpoint now supports the within action. Is that accessible through an add-on? I haven't been able to find information on how to use it. This actually pivots. Julia, I saw your question as well about the Lightning add-on and its USP. So I just want to quickly say we actually kind of did away with the add-on functionality. So we no longer do add-ons. We are using multipliers on specific endpoints. So for our Lightning endpoints, you can now access it through your base level subscription. It just has a different multiplier associated with it. So versus being, you know, a 1x, it's going to be a 3x or a 5x or a 10x. And you will be able to find the within action within those Lightning endpoints. So I can actually share the link to the documentation for our Lightning endpoints in here as well. This is an endpoint related question, obviously. So this is API versus MapsGL, but it would be the same situation for MapsGL layers if you have a MapsGL subscription. The within action, is that available with all of the Lightning endpoints?
We have it in our docs in the core Lightning endpoint. It is in there for supported actions.
Beautiful. I'm going to grab that link for you guys. Perfect. So you'll see that coming through shortly. I can't moderate and search for the link at the same time, unfortunately. And then let me see here. So USP for the Lightning add-on, Julia, just to kind of go back to that really quickly. The real benefit with our Lightning data is the proprietary Lightning network that we use. So the data that we use comes from the Vizsla Lightning Detection Network. So we've got the NLDN, or the what is that? NLDN. No, I'm trying to like remember like what the N stands for. Bad of me to not remember that off the top of my head, but NLDN and then the GLD 360. So we've got North American, and then there's the global data 360. And those data sets are collecting data from sensors. So it's really, really great accuracy and proximity.
Yeah, we operate the best Lightning network in the world. And with that combined feed of those two Lightning networks that we operate, I mean, it really is the best product on the market for Lightning data. And it's because Vizsla has such a great history in being a sensor company. That now that data is operationalized as a feed of data that you can get, you know, you can get it through the API, you can get it through webhooks. It really is a unique product to us, which is great. So yeah, I mean, we power others in the market. Those that are offering other similar things, we might power them. But it really is a unique, awesome ad we have as Vizsla Xweather. It's really, really cool product. So glad you're excited about it.
Yes, for sure. Great. So I just shared the Lightning layers for MapsGL, and then here is your endpoints.
Yeah, and the Lightning subscription, that within specifically is the tough one that requires that kind of enterprise level. But reach out to your account rep. We can totally get you set up and make sure that you're all set with that and on the right page.
Thank you, Samu, for correcting me. National Lightning Detection Network. I brain fart. All right, trying to work my way through these. Freddie asked, what's the bundle size impact of integrating the SDK on a mobile app?
Can we come back to that one? I'm going to see if I can figure that out.
Go look up.
Freddie, we'll come back to your question.
How much does it
So
compile
I'm gonna say finished answering, but we will come back to that. Fantastic. And then Jonas, another question. Can you talk about which layers, raster and GL, are available on Android versus iOS?
So currently on iOS, we have all of our encoded layers, so like temperatures, all of the maritime air quality, and then radar, and then wind particles. On Android, for version 1, it will be the same that iOS came out with for version 1. But the end goal is to have feature parity between JavaScript and the native SDKs as well.
Beautiful. Is there anything specifically, I know off the top of your head, we have a ton of layers, but is there anything specifically that like isn't available yet?
So things like the grid layers, on JavaScript, we have things like wind direction, and then like wind barbs.
Okay.
Those wouldn't be.
Yep.
And then things like alerts, any of those vector-based data sets
Got it.
are not currently on
So as we
native.
kind of work through integrating those in.
Yeah.
Yeah.
Yeah, the plan is to have them all and have them all be very feature parity
Yeah.
together. But as you work through things, yeah, if you can kind of start with some and know that these others are coming, that would be great.
And our docs fully list like what's supported per platform. So if you look at the layers listing, it'll show what's supported on JavaScript, iOS, and Android, and which version.
Perfect. Jonas, I also saw your note sharing the links from previous Q&As. I can also, it looks like Brandon got you those links, so hopefully those are working for you. Thank you, Brandon. Just working my way through the chat here. You guys have great questions. This is
Yeah, this is
fantastic.
like one of the more
Good, yeah.
active ones. This is great.
Alrighty. Jonas says, just back to the use case that you had asked about, Seth, they might implement their own renders, which is why he wanted access to the underlying data.
Oh, nice. Very cool.
Awesome. Craig asked, how can we / the user confirm data accuracy?
That's a great question. So yeah, at Vizela, we pride ourselves in being like the best, the largest weather company in the world. So we believe that good data is from good sensors. So we start at that base layer of how do we provide the best sensors that we can? How do we pull that data from around the world to create the absolute best products available? So we collect forecasts and data from all around the world, whether it's public services like National Weather Services or proprietary models that we purchase. We make the best global representation of weather and the environment out there, which is great. There are some third-party reports that can be purchased. We purchase those to make sure that we're doing, as best as that we possibly can compared to everybody else. So yeah, we're a science-first organization. And then, our team that's here is kind of on that presentation side of, well, how do we represent the data and get it in the people's hands as best as we can? But yeah, there are third parties out there that can help validate it. We run our own internal validation to make sure that we have a handle on things. And there, if you have kind of specific use cases or something, we could run one of those reports for you. Of course, it's us running it, but we do try and be as fair as we possibly can. We're comparing it against like actual data, like a METAR station. So it'd be like an airport, those reference grade sensors. Now, of course, since we're Vizela and we make the best sensors in the world, those are actually our sensors, but we don't control that hardware usually when we sell them. So it's us comparing against the absolute best reference grade that we can for forecasts, for models, for interpolation, all of the things that we're doing.
Perfect. Let me see here. All right. Next question is from Lucas. Are the wind animations currently available on Android beta?
Not currently. That will be in an upcoming beta.
Perfect. Very cool. And then Jonas, I see your question too. Which layers are available where? I am double checking our documentation quickly. Most of our layers are global. And then.
Yeah, is this a regional, as in where, as in geospatially?
I believe so. Which layers are available where? No, not regionally.
Okay. This is more of like iOS, Mac, JavaScript. Got it. Yeah.
Just in case. Yep.
Yep. Awesome.
Just in case. Thank you, Jonas.
Oh, yep. We can switch to.
You want to look at the docs there.
Right. Yeah, so in our docs, as I mentioned earlier, we do list out which SDK and which version each layer is supported in. So you can quickly scroll through here and see, if I go to some of the popular ones, things like alerts, only in JavaScript, and then you can go to conditions, And it will show JavaScript, Apple platforms, and Android, and which versions those are available in.
Perfect. Yeah, I think it's also worth noting. Yes, Jonas, here you go. Our documentation is always improving with the kind of at a glance information that you can see there as well. So our engineering team's been doing a really great job of bringing in the SDK specifically, and then obviously like your geolocations. And then for the endpoints as well, there's the temporal resolution and all of that should be available kind of at a glance as well. So that's really helped build out how quickly you can kind of grab and go for what exactly you need it for, which is great. Slipp, I know you're still working on getting that information.
Had to grab my laptop real quick,
I like
so
that.
sorry.
Unfortunately,
That was
take our
legit.
beautiful maps down.
That was a
yes.
good hot swap over to like, I gotta look up the button
Yeah.
size.
So I am, I'll get you an answer on that, but I'm looking at the demo app from GitHub. Just looking in the .ipa and how big each part of it uses. So
Great.
I'll have a answer in a minute here.
Awesome. All right. We did get a question from Mike here. At times, the MapsGL can take up to 4 gigabytes or more of memory. Are there strategies to keep this memory usage low?
It depends kind of on use case and which layers you're viewing. So some layers are going to use more memory just because it's loading in more data, like radar.
Mhm.
You want that to be high quality and high resolution. But there are ways to reduce that data quality down so it's not loading in so much data. So if you're on like a mobile application, you may want to do so it's not overloading the memory consumption by those browsers. So you can reduce the quality. And then also if you're doing like an animation, then you can reduce or control how much data is loaded for the animation.
Mm-hmm. Awesome. Thank you. Another question from Jonas. I love this. Can we use the beta Android SDKs for production use?
Yes, you
Some
can.
early ones, like we just released the first one. First, I think 2 is coming up soon. So maybe once we get closer to like a later beta, maybe, but
Not
to you.
super recommended.
Up to you, yeah. Use at your own discretion.
Right, yeah. As with any beta software.
Fantastic. Let me see here. One new message. Jonas says we'll wait for September. I think that's probably a fair assessment here.
I have an answer.
Slipp has an answer for us. Great.
Yeah, so
great. Freddie, back to you.
I'm looking at our demo app, the IPA, but unzipped. So what would be on device? The total size of the demo app is 27.9 megabytes. It looks like about 21 megabytes of that is Mapbox, and about 2 megabytes of that is MapsGL, 2.5-ish. And then just the Swift frameworks compiled into the actual binary is another 4-ish megabytes. So pretty darn slim.
Awesome. Yeah, and just as a reminder, the question was, what's the bundle size impact of integrating the SDK on a mobile app?
Very small.
Beautiful. All right. Ziad, thank you. I'm glad you came back. Really glad that you're finding these valuable. And for all of you, thank you so much for joining. I think that covers it. If you have any additional questions, feel free to send us an email and we can answer any additional questions in a follow-up email, get back to you individually, whatever works for you. So keep your eyes out. We will keep your eyes out. We'll send a follow-up email. Keep your eyes open. It'll have the recording for this session, a bunch of resources, and then you'll also get the details on our next developer Q&A. It is currently scheduled for September 24th. It would occur at 11 a.m. Central again. I think we're going to keep this time. It seems to work well. So actually, quick poll for you guys. We would love to know a little bit more about what you would like us to cover in future sessions. So if you have something else that you want to learn a little bit more about, feel free to share it in the chat instead. But this kind of just helps us plan a little bit further in advance. We're really looking forward to doing something at some point in the future on generative AI. So I think that'll be really interesting. We've got some really interesting stuff to share on that.
Yep.
Yeah. Great. Thank you so much, everybody, for joining, and we will see you next time. Thanks, guys.
Thanks,
Thanks.
everybody.